part 3, which we're calling Keeping Things in Balance. We looked at this slightly when we looked at the glucose-glucagon. This is all about, if something gets too high in your body, how do your hormones work to bring it back down? Or if it gets too low, how do we work to bring it back up? Okay, it's a process we called homeostasis. Okay. Your body is always in a state of stable equilibrium. Basically, things keep changing, but what we're doing is we are trying to keep them the same. So the homeostasis, homeo means the same, stasis means stable. And there are lots of things that your body needs to keep stable. Things like your temperature, your blood glucose, your water level, the waist. If you don't keep these things within the correct range, it can be very damaging for you. Just like these poor people falling off the seesaw. So, your body is constantly taking in stimuli and it's processing this information. Okay? Some of that stimuli is coming in through your nervous system. So it might be that it's, your 5 senses are taking in the world around you. Some of it might be through your endocrine system. It might be monitoring some internal changes. Your body's going to respond to this. It can do it in 2 different ways. We can have negative feedback or positive feedback. Okay? We'll look at negative feedback first, because that's the one that's actually most important for homeostasis, but your endocrine system can do both. So we have this thing called a feedback loop. Okay? Basically, hormone 1 goes to the target cells. Okay? Those target cells recognize something's too high, they'll bring it back down. If it gets too low, hormone 2 is released, and then we bring it back up. Okay? So it's basically whatever happens, you'd have 2 hormones, one that's going to be released if the stimulus gets too high, one that's released if it gets too low. Okay? So this is an example of a negative feedback system. Okay, a specific one. Hormones that are controlled by the hypothalamus and are released by the pituitary gland and the adrenal gland. Okay, and what we're doing here is we're saying that if this gets too high, then the adrenal gland causes cortisol to be released, which causes a reduction. If it gets too low, then we have the opposite hormone being released. So negative feedback is working to release or limit the original stimulus. If the stimulus gets above normal conditions, then we lower it. If it gets below, then we work to raise it. Okay? It's a feedback loop, it's constantly being fine-tuned. So we have our normal condition, sometimes called the set point. Stimulus goes below normal, we have a corrective mechanism. Stimulus goes above normal, we have a different corrective mechanism. But in both cases, what we're doing is negative feedback. Whether it gets too high or too low, we are bringing it back to where we want it. Blood glucose is a very common example. Okay, so if the blood glucose levels gets too high, the pancreas secretes insulin. That causes the glucose to be stored as glycogen, so the blood sugar goes down. If it gets too low, then we release glucagon. That causes the blood sugar to rise. The opposite to that is positive feedback. Now, positive feedback is rarer, but it is seen, and it's seen a couple of cases. It's seen in puberty, where one change causes another to move away from the original state. You're never going to go back to that childlike body. It's only going to become more and more grown up. The other one is during childbirth. Okay? You're never going to go back to not being pregnant. We're not going to go back to that set point. We need to expel the baby from the body. So here, this is a positive loop. Okay? Everyone makes it more and more and more intense. So, no one really knows where a positive loop starts, because it's like a circle. Okay? But let's say we start with the head of the baby pushing against the cervix. Down here. That sends some nerve impulses to the brain. The brain stimulates the pituitary gland to release a hormone called oxytocin. The oxytocin is carried in the bloodstream down to the uterus. That causes uterine contractions that push the baby down towards the cervix. So then it pushes against the cervix some more, so then we get more nerve impulses, so then we get more oxytocin, and so on until finally the baby actually comes out. So, here's a few examples. Blood clotting, okay, that would be positive feedback. Sweating is an example of negative feedback because during exercise, body temperature increases, so the sweat produces until we cool down. Breastfeeding is a positive one. Insulin release we've looked at as an example of negative feedback.